Hi, this is, I guess we're going to call this the sampler interface tutorial part 14, though we had a couple videos in between 13 and 14 talking about serial communication with the Arduino and setting up buttons and such with the Arduino. All right, so it's maybe been a while since we looked at this code, but this is the same code we left off at the end of tutorial 13. And basically it got us so that we have a working sampler with a GUI and the ability to loop little bits and pieces of what we've sampled. Okay, so fully functioning looper sampler, which is nice. Now what we're going to do is going to hook up. So we're going to use some of the lessons we learned in the last few videos with Arduino and Serial, and we're going to hook up buttons to control our sampler. So we don't have to click with the mouse with the GUI. We can have some external physical buttons that will actually do some of the same things that would do. And it's nice that we have the architecture set up the way we did, because we just have to sort of engage serial communication, but we can have it just interact very seamlessly, very nicely with our already existing sort of record and play buttons and actions. All right, so let's give it a whirl. We need to set up is just serial communication, and I'm just going to sort of nip and pick from the one tutorial we did, Arduino to processing, and I put some videos there. So the first thing we need to do just to get that rest of that code going is import that library. And remember, there's a couple different ways to do it. You can do it manually by typing import library processing serial, or you can use the sketch import library, and we're going to go serial IO, and that'll just put that text there at the top. We don't need that extra line. And then we had a couple variables that we set up to get our serial machinery working. So we had a serial object, and I called it mine.eno. And then I'm not going to worry about these things right now, because in fact, we're already have that machinery set up to do its stuff. Okay. Now, then let's move to setup and set up the serial bits of this. And I can either do that before or after OSC. Might as well just do it after OSC. And then I am going to put this line in, print ln serial dot list. So that'll print a list of all the serial objects attached to your computer at the current time. So if I just simply do that and run this, I'll get a printout of the list of serial objects. And let me get this back over here. So we have the whole list, and then we'll just count from 0, 0, 1, 2, 3, 4, and that's 5. So that is the one we're using, this USB modem 1D151. That's my nice Pro Micro here. And I'm going to now set that one up. I just need to know which one it is. So I can comment this out, so we don't need to print that every time. Go ahead and stop that. And if we look, we're just going to use this. We're going to create a port name. That serial.list produces an array of strings, and we want to grab the string number 5. A lot like how we set up it in Arduino in our last video. We just, actually manually copied and pasted the text in there. That's essentially what's going on here. We're just putting the text in and saying, use this, called this, use this port, called this. Okay, so we're going to say, let me just remind myself of the syntax. String port name, serial.list. Okay, so string port name equals serial dot list number 5, or the 5th, so the 6th one really. Okay. Then we're going to initialize our serial objects. We're going to say eno equals, and remember we declared this up here, eno, serial eno, new serial, and this and port name. It's going to be a new serial object, and the arguments are that's context, which is everything this, and the port name, which is then port name, which will grab that whole bit of text there, dev tty USB modem. And I suppose you could just type that in as well, just like you do in supercollider, but this way it's done for you. So there's no typos there. All right, so now with those lines of code, we have our serial object set up within our sampler. So now it's ready to receive serial data. Now the one thing I want to do is, because it's not necessarily true that your Arduino will be plugged in every time you want to run this code. So I'm going to set up a little gate that allows you to go into your code and turn it on or off, the serial bits. Okay, so let's create a Boolean, and we'll say serial, we'll call it serial on. And let's make it true for now, because I do have my thing plugged in. But if you don't have your thing and you just want to use the GUI, you don't have your Arduino plugged in, then you can just change that one to false. And then we're going to go into draw, I believe. And yes, right. And then we're going to do all that code. Okay. So I suppose we can do it at the beginning of the code. That's fine, of draw. And the first thing we're going to do is put in that gate, that Boolean gate, if serial on. Okay. To make sure that the serial thing is true. And then we can change it to false, and it'll just ignore all this altogether, and we won't have to worry about if a serial object is plugged in or not. Did I do that to this here? Ah, right. I did it over here. Okay. All right. So, yes. I did it to both places. Yes. Okay. Right. So we do have to do the setup too. That makes sense as well. So if we don't have our serial object, having our Arduino plugged in, we can't run these bits. It'll balk as well. So we'll say if serial on. Okay, good. Now back to the draw. And so we'll enter the same bits of code that we did when we just were doing Arduino to processing. And the first thing we're going to see is the Arduino available. I guess it's kind of a double check. And I guess it gives an integer, so we have to say that if it's greater than 0. It's not a Boolean. So let's go ahead and put that if statement in. If eno.available is greater than 0. So if it's available, it could also be that that serial port is being taken up. Say we were running something with supercollider, we forgot to shut it off. So we're just double checking to see that it's available. Right, okay. Then we're going to read the message that comes in, okay? And I guess we're making this available everywhere, but we don't necessarily need to do that. So we'll make it a local variable. Okay, so we're going to create a string that's going to be the message that comes in. No, this is the wrong one, sorry. Right, this is still in draw here. If it's on, if it's available, we're going to create a variable here. We're going to call it string. And we're going to call it SMSG, the serial message, equals. And let me just double check that. Eno.readString, okay? Eno, my serial object, dot read string. Run that function on it. Yep, run that function on it. So now the string SMSG will be the string of things that come in through our serial port, which we expect to look like BT whatever 0, 1, or 2, colon, and that's it. Colon 1, right? Or colon 0, colon some value. All right, now we have to do the whole split business. So I'll just go through this quickly because we did go through this. So we're just go split. We'll say string, a string array, and we'll call it empty1, I guess. Equals split. Oops. At the return. Split the SMSG at the it's a // sorry, just /r. /r. Okay, so so that just splits it and creates an array. So again, I'm just just gonna jam through this because I've covered this in detail. So then we're gonna add the mt1 dot shorten. Oops. mt1, right? Because for some reason processing doesn't cut out the hard return, but it sends. I mean, Arduino doesn't. It takes that hard return coming from Arduino, so we have to cut the last one off. Otherwise, we have an empty thing in our set, and it's going to throw some errors. And then we're going to go through this thing mt1, which is our split message, and we're going to split off. We're going to split off the two bits parts of it, which are the header and the value. Okay, so we're going to do for loop. Int I equals 0. I is less than mt1 dot length I plus plus, and we're going to do a bunch of things. First thing we're going to do is create another string array, and it's going to call mt2, and it's going to be mt2 string array mt2 equals split, and we're going to split mt1, except this time we'll split it by the colon. So that's going to separate our header and our value. Okay, and then now, just like in SuperCollider, we're going to have a bunch of categories here. So let's go BT, we'll make that BT0. Okay, and then we'll say if MT2 number 0, the 0th is, now we have to do that a bit strange syntax for comparing strings within processing. So dot equals, and then the string we're comparing it to, which is BT0, and if that is true. Okay, then we can have our value. So if it's BT0 is true, then we grab our value. So which will be MT2 1, right? So now let's have a look. Now this is kind of where we have to remember how our code worked before. In order to engage, oh, it should be here anyways, sorry. So let's say we want to use that first button to start recording on track 0, or the first track, okay? So let's see how we did that anyways, right? It had something to do with those buttons that under mouse press. So we have to go, play record buttons, that's just the drawing part. If we go all the way over here to mouse pressed, right? Turn record on off. Basically, we're saying, is it over this track? And is it less than 17, which means is it over there? And is it over one of these buttons? If it is over one of these, the record button, the red button, then we're going to toggle on our rectogs for that track. Okay, so we're gonna this whole bit, this modulo 2 and rectogs plus 1, rectogs equals rectogs I equals rectogs I plus 1 modulo 2, just toggles it between 0 and 1 for that track. Okay, and then we have our messages here that say if it equals to 1, send that message. If it equals to 0, send that message. Okay, so we just got to copy those bits, and for some reason I feel like we didn't do all that. Because it already sends it, does it? Sorry, read serial port. Button 1, button 2. Yep. Right, okay. And, well, okay. So I guess we just send it directly here. Sorry, this is my old code, my original code, and I seem to have handled it slightly different way. All right, so it's in draw, I guess, is it now? If rec on, where do I send the messages? Well, that's okay. Seems I'm not sending messages in this one. I'm not sure where I send the messages. Okay. Well, I won't bore you with the searching. So I'm a bit obsessed now. So OSC said, right, okay. Or maybe I just use your shorthand. That's all I did. I think that's what happened, yeah. I am sending messages there, but I just use a strange shorthand. No, I didn't. Oh, well. Anyways, we'll just stick to this. So if I turning record on and off with my buttons, I'm going to go through the same bit. But we already have all this in place. All right, so yeah. So the first thing we'll do is we update our record toggle, okay? So go back up to where the buttons are pressed. Okay. And if it's equal to 0, we can assign any function to it. So maybe I'm wondering if that's what I did to make a function. It might be easier to do that, but I won't. I think that will confuse things a little bit, so I won't do that. So the first thing we need to do is just update our record toggle. All right. So we'll say rectog, rectog, and then we already know we're going to control track 0, or so we'll say rectog 0 equals itself. We're just going to toggle it on and off. Equals itself 0 plus 1. Okay, and then we'll have to modulo that so that it continues to just oscillate between 0 and 1. So modulo 2. All right. So it's going to oscillate between 0 and 2 every time we press that button. No, but the problem is it'll do it on release too as well. All right. So what we'll do is we'll add the empty to 1, okay, as an integer. So we'll have to convert that to an int, int, and I'll explain this to you. Empty to 1. All right. And so what are we doing there? What we're doing is we're taking empty to 1. So this split right here is splitting the header from the value. So BT0, and then if it's pressed 1 or 0, and then this is comparing the header to BT0. So we're only dealing with the button 0 here, and this is basically saying go ahead and update this rectog, but just by the 1 if it's pressed, okay, which is empty to 1, okay. But in order to add, we have to convert it to an integer. So that's why this int parentheses is there. Empty to 1 converted to an integer, which is either a 1 or a 0. And the rectog will either be on or off. So if it's released, the button is released, it's 0, and so it does nothing. It just, whatever it is plus 0, right, is nothing. If it's pressed, it'll be 1, and we'll add 1 to the rectog. So if it's already recording, when we press it, it'll turn it off. If we press it again, it'll turn it back on. And that's that modulo 2. Okay. So if we do that, and sorry, I'm a little bit obsessed. So I'm going to look here really quick to see how I handled the OSC messaging, because we have to send a message to SuperCloudr saying it's time to record. And it seems like I did that kind of sneakily somewhere. Cursor and then track cursors. Seems like I only did that on mouse press there. See, I didn't even do it on mouse pressed, mouse released, key pressed. And which track? I made, right, okay. I made a function, and that might be worth doing just because it is a lot of repeating things, okay? So let's go ahead and follow that strategy. And we can leave, we can leave our GUI buttons the way they are instead of like replacing all that text. But maybe we follow this strategy for this one so it doesn't get all verbose up where we're coding. Okay, so why does rectog not exist? Rectogs. Okay, so sorry, this is rectogs. The new IDE has these little catcher things, except they think faster than you, so it's telling you're doing things wrong while you're still trying to do them. Okay, but it does catch these errors like that, which is nice. So what I'm doing is I'm going to write a function that basically does this. It sends that OSC message to record. Okay, so we have a record, a play, and a pause. So if we look at where we mouse pressed, play, pause, and then record on, off. Okay, so we have a rec on and a rec off. And let me see, do I have a rec off? Right. Track number. Okay, right. Okay. So this is how we communicate with SuperCollider to say start recording, right? We send this message rec on, we add a track number, and then we send it to SuperCollider, right? So I'll go ahead and copy that because I'm just going to make a function down here that's going to handle that, and will just be one line of code and make things a little bit handier. So I'll label that record on function. Okay, and I'll say void rec on, and then I'll put one argument in there, which will be the track number. Okay, and then I'll paste that business in there. So if we call this function, it's going to send this message record on to SuperCollider, and it's going to send it to that track, TR. So we're going to add this track number here and then send that to message. So it's just a shortcut, so we don't have to keep repeating this text over and over again when we want to do it. Okay, because we'll have various things to do that with. Okay, so let's make and actually, well, I was going to say we can have we don't have to make two functions. We can have one for record on and off, but let's go ahead and make two functions. It might make it a little clearer. Okay, so record off function, and we'll say rec OFF, and we'll say OFF here. So we're gonna, if it gets rec off function, it's gonna send that message, and it's gonna add the track number, and we'll change this to all the messages here. We have to make sure we do that for everything. Okay, rec off roff.add roff send. Okay, and then we might as well, since we're down here, create a message for play and pause, because we'll get to that as well. So same thing, but I'll just copy this bit of text here to send that OSC message. Okay, and I'll create a function here. I'll call it play function, and then I'll do void play, and again an int of the track number, and the curly bracket scope. Paste that OSC message in there. Control T to line everything up. So this play message is going to send play, and it's going to add the track number, so TR, and then it's going to send that to SuperCollider. Okay, and we'll have the same thing, except we'll have a pause function. We'll call it pause. And I'm just going to see what we call pause. Pause is the OSC name as well. So we will send track number. We're going to see PS message, just make sure you update those. And then we're going to send pause to SuperCollider, add the track number, pause message, that's fine. And we'll just change that to pause as well. Okay, so we have four functions now: record on, record off, play, rec on, rec off, play, and pause. Rec off, rec on. Okay, so now the fruits of our labor will pay off when we go back up to the serial part. And we can also, if we wanted to, and I won't do it, but I'll just show you, if you wanted to just change also the mouse press, the GUI buttons that are pressed, we can just replace these three lines of text with rec on and then the track number I. Okay, but I'll show you how that works up here. So when we get that serial message in, and if it is BT0 that comes in here, we compare that, and it is BT0, then we're going to update the record toggle, okay? And then we're going to base it on the record toggle instead of the MT21. So we'll say basically if rectog 0 is equal to 1, that's record on, then we'll run the function rec on, and with a track number, which is 0. Okay. I'm pretty sure that's how I handle that. Let me just look. Let me double check. Rec off, else rec off. Right. Yep. Okay. And then, then we can just do an else if it's not 1, or, so then if it's 0, else. And we're going to say rec off, and then send the track number 0. Okay. So we're going to use the 0 button, the first button, to record on track 1 or track 0. And then we're just going to copy all that text there. Okay. See where that if ends. So make sure we capture that end of if. Oops. And then paste that there. So now this will be BT1. And I guess we can make BT1 since we only have 3 buttons, and of course, let's say you have 8 tracks, you can make as many buttons as you want to do as many different things. I'm going to have 3 push buttons and then add some other devices later in future tutorials. So we'll say button 1, and we'll say this MT2 0 equals BT1, right? So MT2 is that split thing, message coming in from the serial port, and it's the header, right? So we're going to see if the header, MT2 0 is the header. We're going to see the header is button 1. If it is, we're going to make it rectog 1. So that's for track 2, or the 1th track. So the track 2, rectog 1. And we're going to update that. And MT21 still, just because that's the other half of it. It's not the header, but it's the value, right? MT21 represents the value. Okay. And then, of course, modulo 2 oscillates between 0 and 1. So now we're going to update that to say if record toggle 1 equals 1, then record on track 1. Else record off track 1. If record tog 1 for track 1 equals 0, which is what the else signifies. Okay, so button 0 is going to record on and off, toggle recording for track 1. Button 1 is going to toggle on and off track 2 or 1, whatever. It gets really confusing when you start counting from 0 or you don't. But I think it's more colloquial to say track 1. You don't say track 0. Okay, and then we have one more button, and we might as well use those play and pause things. So I'll just go ahead and copy it as well. I'll copy all that text, and I'll paste. Sometimes it is good to type, though, if you want to get used to this stuff, but so you don't have to watch me type. So button 2, BT2, now we'll control play pause for track 1, say, or the 0th track 1. So MT2 still 0. That's the header side, is BT2. Then we're going to control play and toggle for the first track, which is rectog 0. All right, I'm sorry, we're not going to use record tog. We're going to use play tog. Play tog 0, right? Because we're using the play and pause. Play tog 0 equals plus MT1. So if it's I'm releasing it does nothing because it gets a 0. If I'm pushing it, it gets a 1 here. MT2 1 equals 1, and then convert to an integer. And then still modulo because it's a toggle. So then, of course, play togs 0 for the first track equals 1. Then play track 0. And then else, if it's equal to 0, if play togs is equal to 0, that's what the else stands for. Then play pause track 0. Okay. All right. So now we have our 3 buttons hooked up. So hopefully it works okay. And I'm not going to start the super collider part because you can visually see that it's working. And I suppose we can run the super collider part as well, but let me just visually see if it's working first, okay? And I don't have to change anything with my Arduino because it's still running the same code from the last tutorial. So if I run that, okay. So, okay, I maybe spelled it wrong. Eno, A-V-A-I-L, A-B-L-E-O-N. It's a function. So it's a function. It just needs these brackets there. Okay. So you want to add that. Oops. Okay. So, yikes. All right. Okay. This has to be, I guess, single quotes. Oh, no. It doesn't like it still. MT2 is splitting MT1. And then it's the character colon. All right. Oh, right. I'm sorry. Okay. So this needs to be actually a single string, right? So MT1 is this array of strings, which is every message that comes in, if I get a list of them. So I just have to go MT1I, right? That's why we're using this MT1.length, this for loop. It's going to go through all the ones. But I guess I've formatted Arduino such that everyone will be its own thing. So I might not even need that for loop. Yeah, sorry to go back over things and do that, but I think hopefully you understand what's going on enough that you understand the changes I'm making. So I'm going to presume that every message I send, because I do a print line here, just sort of stands on its own. So I might not need that for loop. Well, I'll tell you what. Let's leave it how it is, because I think it's fine. And I just needed to add that MT2, MT1I, right? Because MT1, so the message comes in, reads a string, and it's just splitting at the hard return, okay? And then I might be able to eliminate all this. And that means I taught you wrong in the previous video. So I'm wondering if I don't have to shorten or anything at all, and I can just, maybe because it already sends that return. So let me just see what happens if I just print this SMSG. Okay, so print SMSG. So bear with me, a little bit of troubleshooting here. Okay, and then if I just push one of my buttons, oops, nothing's coming in. All right. Okay. Well, I'll be right back. Well, it turns out I can potentially simplify this code, but I probably decided not to. We'll just keep it essentially the way things are. But just understand that every message that comes in will be kind of its own array. So some of this is slightly redundant, like this for probably could be gotten rid of. And if you change that I to just MT10, because there'll always just be one item in there. But let me not confuse things any further and just keep this going on. So basically, where we were was having this thing come in, and I'll just get rid of that print line too. So it's coming through. Okay. So I just made the mistake way 2, 3, 4 mistakes ago when I first started this, is just I needed to declare I here. Okay, because it's in this for loop. So it needs to split single string. Split works on a string and creates an array from one string. And this is an MT1 is an array of strings, but MT1I is a single string, which will always be just one item there. Okay, so this should just work anyways. Back to the drawing, we're back to where we started. And so if I press 1, as you see, just make sure I'm on camera properly. Yeah, I am. So if we press 1, as you see, it turns record on or off. And if I press button 2, it should record on and off track 2. And if I press 3, it should play and pause track 1. Okay. Well, great. That works very nicely. So that's us hooked up with physical buttons now instead of the GUI. And as you can see, well, you haven't seen yet, but you know the GUI buttons still work, but also the physical buttons work as well. Okay, so you can control from either way. Okay, so you have those two options now. And now, in the future videos, we're going to create different types of devices to control our record and play, etc., and possibly loop as well. Okay, let me just do a quick review as to what we did. What we did was we're hooking up to our GUI the processing bit, the physical buttons into our GUI. So we decided to use serial communication through processing. You can also receive serial data within SuperCollider, but here I figured we'd interact with the GUI, and then the GUI would pass on information to our SuperCollider. Okay, didn't test to see if SuperCollider is working, but it's the same information being passed on. So we set up our serial object, and we went through all this serial and the setup, the serial object. And we created an area here that we're going to just check to see if serial on. And remember, you can always change that Boolean up here to false if you don't have an Arduino plugged in, and still use your sampler through the GUI. And then what we did was, we went through all this stuff and split just like we've done in a previous tutorial. And did all this stuff to get the header, so we can sort for whether it be button 0, button 1, button 2, etc., depending on what header we send from Arduino. And just for ease of things, when we want to actually, so we wanted button 0 to toggle record on and off for track 1. So for ease of things, we created a function instead of for every time writing the OSC message and OSC.add and then .send for each of these. It gets kind of verbose that way for each of those, each one of their here. What we did was we created some functions down at the very bottom here. We have a record on function and record off function, play function and pause function. What's essentially just is almost like a variable. It's a function, a placeholder, an abbreviation of sending that message there. So when we run pause and we give it a track number, it will send that message to that track number, OSC pause to SuperCollider. Okay, and then to declare those functions, we we just say rec on 0. So if, for example, if we wanted to replace these down here as well, we can do the same with our mouse press buttons. So this is record on. So these 3 lines of text can go away, and we can just simply say rec on and then I, because that'll be the track number. It'll be I. Okay. So, and we can even use the abbreviated if without the curly brackets. Just put it all on one line. Right. And the same with this. We can just replace all that with rec off. Say rec I. Okay. So that makes things a lot more compact there. And you can go through, and do the play pause as well. So replace all that, even the curly brackets there, with play, the play function, and then I. And then else if, we'll replace all that with the pause function. And I. Okay, so that makes things a little bit tidier and easier to see, I guess, things a little bit clearer and tidier. Okay, well, good luck with that. I hope that works out for you. And this is exciting. Now we have, not only do we have just these buttons connected up, but we have just the architecture to use any sort of physical controller. And as long as we're sending those headers and the same kind of message, and as long as we know what to parse for, then we can use, say, I guess in future tutorials, I'll do capacitive buttons or I'll do accelerometers. Perhaps we'll get to, light sensing resistors, those kind of things. You can, or force sensing resistors, these sort of things to create these messages through the serial port. So you can have a physical controllers for our samplers. Okay, well, good luck with that.